again and welcome to Spotlight, the interview show on our team. I'm Al Gurunov, and today my guest here in the studio is Osamu Motojima. Nuclear energy is a part of our everyday life. Well, actually 15% of world energy is generated on nuclear power plants. But after the incidents at the Soviet Chernobyl and the Fukushima plant more recently, people started to be more cautious about using nuclear energy. Some say that we need a new approach. This new approach is using fusion instead of fission nuclear energy. Well, it may be science fiction, but there are people that believe that soon fusion will be the power source in the world. One of these people is Mr. Osamu Motojima. He is the general director of the power plant called ITER, the ITER project in the south of France, which is a great experimental nuclear reactor.
After the disaster at the Fukushima nuclear power plant, the world became much more concerned with nuclear safety. Germany even decided to phase out its nuclear power facilities. Long before, leading countries including Russia had joined forces to work on a safer and cleaner sustainable source of energy known as nuclear fusion. The project is called ITER, and although unfeasible in the beginning, the reactor that could finally generate fusion energy is being built in France. ITER Director General Osamu Motojima says the project is a gateway to the industrial use of thermonuclear energy.
Hello, Mr. Motojima, and thank you very much for being with us.
I'm very happy to come here.
Okay, well, first of all, I wanted to start talking about the project that you're working out, which is pretty unique. We know that nuclear fusion that you're working with now was used in nuclear weapons like half a century ago. Well, in nuclear bombs it was used already. So what's so new? What's so unique about using it in a reactor? What you were doing?
Yes, that question I sometimes asked. And you are talking about the relation with hydrogen bomb, with fusion energy. And our objective by ITER project is purely peaceful usage to demonstrate the energy source of fusion energy. So, unfortunately, hydrogen bomb was thought just after World War II, but essentially mechanism is the fusion, but some of the material are the same, but our magnetic fusion based on very different mechanisms.
So the principle of work is different than in the hydrogen bomb. So it's
yes.
Okay.
Yes.
Listen, another question from the man in the street, as we say. Although fusion power is nothing new, as you said, for many ordinary people, it's still a little bit of like a science fiction. Yes. How do they treat your ITER project? Aren't they afraid, like people were afraid when they built the CERN large hadron collider?
Yes.
They're also afraid. They said it will be the end of the world. So are they afraid of your power plant?
Yes. The fusion research was declassified in 1953 in Geneva IAEA conference. And immediately after, the peaceful usage of fusion energy started. But at that time, it was the experiment and the theory on the tabletop device, just a small device. And it was dream in the past. But nowadays, fusion energy, we are trying to demonstrate by ITER. ITER is the experimental thermonuclear fusion. What we are trying to demonstrate is fusion is not a dream, but become real target.
But can people be afraid of that reality? Can they be afraid when they hear the word experiment? with nuclear power. They say, we don't want to be a part of that experiment. Does this happen?
Yes, what you mentioned related to serum is somewhat related to the small black hole is made. And our basic principle based on is Einstein's most beautiful formula, people say, E equals mc squared.
Yeah.
So the nuclear fusion is the reaction to light material like hydrogen isotope fuse and become helium. And in this case, according to the Einstein's law, E equals mc squared. M is the mass and C is the light velocity. A huge amount of energy is produced. Therefore, mechanism is very clear.
But
people need not
the
be
mechanism.
afraid.
The mechanism is clear, but to use it, as you said, in peaceful means, just to release the energy is a bomb. But to use it in peaceful means to tame this energy. It's like to take a wild animal and bring him to the circus, yes, and tame him. Was it hard to do that? Was it a difficult problem?
In our fusion reaction, we use one word additional. That is the controlled nuclear fusion. So the typical explanation to you is fuel inventory of the core of future fusion reactor is only 1 gram. So the fuel inventory is very small. This is big difference from fission reactor. In the case of fission reactor, several hundred tons of uranium or plutonium fuel is inside of the reactor. So once it's become uncontrollable, then Fukushima-like accident occur. But in the case of fusion, why we say controlled fusion? This is intrinsically safe since fuel inventory, so hydrogen isotope, deuterium, that is the non-radioactive material, and the tritium, also the isotope of hydrogen, we should be careful since this emit beta radiation. But we already developed the safe handling technology. So the tritium and deuterium fuel exists only 1 gram. It corresponds to about 8 tons of petroleum. So the energy inventory is very small. Therefore, it's very, very easy to control. If something happens, like terrorist attack, extreme case, fire occurs, and tritium explodes, but the radiological impact to the people nearby is only background radiation level. So this is very important.
And this background radiation level, is it low?
It's very low. So we are living in.
It's not dangerous.
Not dangerous.
Listen, I think that what you say it's probably true, and the proof is that the French authorities recently they gave you the permission to build the ITER tokamak in the south of France. Was it difficult for you to persuade the French to get this permission?
Yes, we input a DAC file like this, and more than 2 years it is evaluated. And French has a very, very advanced and strict nuclear law system. So according to this nuclear law system, our DAC file was evaluated. And important is how to evaluate it by public people. So it is called public inquiry. And the French authority organizes a special commission. And this commission last summer made public inquiry, and more than several thousand of questions come and we answered.
Why did you? Why did you select France? Because France has always been a pioneer in nuclear technology. Is that the reason?
Yes, I think so. Since why I say I think so is for a long time Europe and Japan competed, and Russia supported France. China and Russia.
Listen, the project, the ITER, it costs over $20 billion US, right? Who's paying? Is it raised money or is it taxpayers' money?
Oh, certainly taxpayers.
Taxpayers' money.
So we have a large responsibility to the taxpayer and the stakeholder. But the $20 billion, so it depends on how much amount each member invest. So Europe is the host member.
The European Union invests more than about a half, yes?
45%.
EU, 45%.
And the European Parliament capped the cost. It is 6.6 billion euro. So it depends on other members' budget system.
And the other members, if I'm not mistaken, are India, Japan, China, Russia, South Korea, and the United States.
And the Japan.
And Japan, yes, I
yes.
mentioned Japan.
Yes,
and they all pay about 9% of the budget.
Yes, correctly, 9.1%.
What do they get in exchange for that money? Well, what will Russia get?
That is the government budget, and Rosatom has the responsibility for to secure the budget. And very important point. So all of the intellectual property achieved by ITER project unanimously shared by 7 members. Why I mention member is Europe is 23 countries. So usually we use member. So other 6 members pay 9.1% and take everything, every result.
Says Osamu Motojima, a nuclear scientist from Japan who's working on one of the most modern nuclear projects in the south of France. We'll continue this interview in less than a minute, so stay with us. Don't go.
Download the official RT application to your cell phone, choose your language, stream quality, and enjoy your favorites from RT. If you're away from your television, well, it just doesn't matter. Now with your mobile device, you can watch RT anytime, anywhere.
There are 12 cities in the United States in which half of the people with HIV/AIDS lives.
Within a year of a diagnosis of HIV, over 62% of those patients are diagnosed with AIDS.
This is a problem that, frankly, is substantially preventable.
It was like the big elephant in the room and nobody wanted to talk about it.
There were really good public health campaigns. If people were really focused on this problem, you certainly should be able to have a lot less HIV, a lot less human suffering.
Choose your language.
Good morning from me, Kevin Owen. If you're sanitation semanal.
Choose the news that concerns you. Choose the opinions that invigorate your mind. Choose the stories that impact your life. Choose the access to your RT.
Permission free. Accreditation free. Transport charges free. Arrangement free. Risk free. Stereotype free. Download free broadcast quality video for your media projects at freevideo.rt.com.
Welcome back to Spotlight. I'm Al Grunov, and just a reminder that my guest on the show today is Osamu Motojima, a nuclear scientist from Japan who is working on a most recent nuclear project in the south of France. Actually, it's a great new nuclear power plant. Mr. Motojima, we talked about the funding of the project, that it's a joint project of the European Union and a couple of other countries, including your country, Russia, United States. According to European media, some big names in physics, including Masatoshi Koshiba, he's the Japanese Nobel Prize winner in physics, yes. They criticized it. They say that it's just a waste of money as the project is too costly and unstable. Why do they call it unstable? Why do they call it unusable? How can you persuade these people to change their mind?
Mr. Koshiba is a famous scientist, and his specialty is neutrino from sun. So I'm not sure why he mentioned not stable, but before ITER organization was created, 2007, more than 10 years passed for the negotiation of the project cost or size, or finally it is the site selection. Therefore, I guess, I did not confirm, but that is a point he mentioned, not stable. But already in Kadarash, construction started. I think ITER come back to the right track and now trying to increase its velocity to the goal.
Well, as you remember, the Chernobyl disaster, it led to years of public debate, of public opposition to nuclear programs. The Fukushima tragedy in Japan intensified the negative feeling, right? Well, Spotlight's Yelena Demidova has more of that.
Nuclear power plants exist only in 30 countries of the world. 45 more states want to join the club, while some of the current members have announced they are leaving. The most controversial of all types of energy, nuclear power has always been high on the political agenda. It's not that easy for policymakers to reject something which has so many advantages. Despite the potential risks, nuclear power is more eco-friendly than oil and gas, with low carbon dioxide emissions. And it's also cheaper than hydrocarbons. Besides, global uranium reserves will last for much longer than oil and gas, around 600 more years. But the 1986 Chernobyl disaster showed how dangerous even the peaceful atom can be. Human error was the cause of that accident. At Fukushima, the possibility of human error was almost totally ruled out. What no one expected were an earthquake and tsunami hitting almost simultaneously. Besides, 50 minor accidents occurred at power plants across the world in between Chernobyl and Fukushima. They weren't much spoken about as they did not cause casualties. And after Fukushima, people all over the world went onto the streets to protest nuclear energy. According to the French Atomic Energy Commission research, no technical innovation can eliminate the risk of human error in nuclear plant operation. A team of scientists from the Massachusetts Institute of Technology came up with an estimate that given the expected growth of nuclear power up to the year 2055, at least 3 serious nuclear power accidents would be expected in that period.
Well, would you agree to that estimation of MIT? Because this is a respected institution, so they predict 3 major nuclear accidents in the near future. Would you think that will happen?
For fusion,
yeah.
I'm asking. So, as I mentioned at the beginning, the mechanism of fusion is different.
Well, yes. This is very interesting. If I can ask you to explain to the viewers, making it easy, the principal difference between fusion and fission. Why is fusion safer?
Yes, since in this movie, the many fuel are shown. In the case of fusion, we need not use uranium. So this huge amount of uranium fuel does not exist in fusion plant.
So you don't use radioactive materials as the source of energy?
Like uranium. Correctly speaking, we need to use tritium as fuel. That is radioactive material. But never emit high energy radioactivity, and also long life high radioactive waste is not produced by fusion.
You said that this is what you're doing now is an experiment, but do you think that in the future, if we continue predictions, do you think that fusion power should replace the usual atomic energy?
Yes, it depends on the success of ITER project. So it's early to decide, but
so if Mr. Koshiba is mistaken, then you will succeed, right?
Sometimes Nobel Prize winner make mistake, I think, in the history. He also mentioned the very harmless of the tritium. So 1 gram of tritium kill more than 20,000 people, like that. In my memory, this is absolutely not correct.
Well, but still, I understand you're a patriot of your project, but everything has disadvantages.
Yes.
Can you mention the disadvantages, the weak points of your project on which you still have to work on?
There are several. First of all, fusion was more difficult than fission, so it took a long time. From 1958, after declassification, already almost 60 years passed, and now we are reaching to the goal, demonstrating 500 megawatt thermal output. So this value, 500 thermal, is large enough to ask public people or government to decide to utilize fusion or not. So I believe 2 or 3 members from 7 members will soon decide then to construct the next step demo. And another point, since fusion is very difficult and also a lot of components, superconducting magnet, vacuum vessel, or the tritium handling system like that. So more complicated systems than fission. Therefore, we need to spend more effort to reduce the cost of machine. So it will be implemented in the next step after ITER project.
After the Fukushima incident, which was the latest big nuclear incident, well, the nuclear power fell into disgrace around the world. People became afraid of it, and you understand that. Well, it suddenly occurred to me, did it help you? Did it promote fusion? I mean, do people understand that it's something different from the plant in Fukushima? Or, on the other hand, people say, oh no, if this is atomic energy, this is bad. I mean, did it help you or not? Or did it create additional problems for promoting your project?
I think the people's understanding on fusion is increasing, I think, gradually. So this is the evidence you invite me to this studio and talking about fusion. I think this is, for me, very encouraging. But it's gradually increasing, but it takes some time more.
It takes some time. But how much long will it take to make fusion power commercial? As far as I understand, your project is not going to be commercial yet.
Yes, our project never produced electricity, only thermal output of 500 megawatts. So that is a very important point, and we will demonstrate 500 megawatt after 2027, and the machine will be completed 2020, so soon. And after demonstrating 500 megawatt, we call it ignition. Then we can move to the next step. Therefore, demo construction, it takes 10 years, and beforehand licensing process, design process, all of the intellectual property achieved by ITA will be transferred to this process. So my expectation is depend on the investment, certainly, but 2040 to 2050.
40 to 50.
Yes, we can make electricity and send it directly to the electric grid.
But we're talking about alternative. Well, today we talk about your the fusion as an alternative source of energy. But can you personally name some types of alternative energy that can be alternative to fusion in 13, 50 years? Can that happen? Or you think there's no alternative to nuclear energy?
May I ask you, so the alternative to fusion?
Yes.
like renewable energy,
well,
do you
wind
mean?
or whatever, I don't know.
Yes. Yes, we should have several options to have the redundancy and healthy energy system. So fusion, as a fusion researchers, I hope to contribute it, one of the big option. And to make decision is you. So at least we need to demonstrate before any expected crisis come, fusion is possible. If once crisis come, it's too late to develop fusion. So ITA is very important role. We can do to demonstrate. And to decide is you, I think.
Thank you. Thank you
welcome.
very much. And just a reminder that my guest on the show was Mr. Osamu Мотоджима, the Director General of the ITER nuclear project. And that's it for now from all of us here at Spotlight. We'll be back with more. Until then, stay on RT and take care. Thank you.
Thank you very much.
Arigato.